Welcome to an introduction to modeling with linear functions. In this video, we will look at a problem-solving strategy and use it to solve an example problem. Let's get started. When we say that we're modeling with linear functions, this means that we use a linear function such as f of x equals mx plus b to solve an application or word problem. Here are the keys to being successful when solving word problems. First, take your time. Solving a word problem will typically take longer than just solving an equation. Second, read the problem twice. In fact, you may need to read the problem 3 or 4 times. It's also recommended that you may want to read the problem out loud to also hear the problem as well as read it. Finally, think carefully about the problem. In this video, we'll go through a strategy and you'll see that it takes time to solve an application problem. Be patient with yourself, but think carefully about each step as you go. Okay, let's get started with our strategy. Here is the 8-step problem-solving strategy. This strategy can be used to solve most application problems, not just those that involve linear functions. I've linked the problem-solving strategy steps in the description below in case you want to copy and paste them into your notes. Here is our example problem. Jamal is choosing between 2 moving companies. The first, U-Haul, charges an upfront fee of $20, then 59 cents per mile. The second, Budget, charges an upfront fee of $16, then 63 cents per mile. When will U-Haul be the better choice for Jamal? Let's take a look at the first step in the strategy. We need to identify changing quantities, then carefully and clearly define descriptive variables to represent those quantities. When appropriate, sketch a picture or define a coordinate system. Let's go back to the original word problem. We can see that each company has a specific cost. So cost is going to be one of our variables, and the other one is going to be the distance or the miles traveled. We also need to note here that we have 2 companies, U-Haul and Budget. So since we have 2 companies, we're probably going to need 2 functions. Let's write down what we know from the word problem here. We have 2 important quantities, cost and miles driven. We have 2 companies, which means we're going to need 2 functions. Our inputs will be represented by the letter X, and this will be miles driven. Our outputs will be Y of X, that will be the cost in dollars from renting from U-Haul, and B of X will be the cost in dollars from renting from Budget. Now in step 2, we need to carefully read the problem to identify important information. Look for information giving values for the variables or values for the parts of the function model, like the slope and initial value. So for U-Haul, we have an upfront cost of $20 and then 59 cents per mile. It's important to note that we need to convert cents to dollars so that all the units match. For Budget, we've got an upfront fee of $16, then 63 cents per mile. Let's summarize our costs. U-Haul had a fixed cost of $20 upfront, and the variable cost was 59 cents per mile. Notice that I've converted that to dollars instead of cents. And Budget had a fixed cost of $16 and a variable cost of 63 cents per mile. In step 3, we need to carefully read the problem to identify what we're trying to find, identify, solve, or interpret. Toward the very last sentence, we see that we are trying to find when will U-Haul be the better choice for Jamal. So we're trying to find, or we want to know, when the U-Haul will be the better choice. Since all we have to make that decision from is the cost, we are looking for when U-Haul will cost less, or in other words, when the y of x function will be less than the b of x function. In step 4, we want to identify a solution pathway from the provided information to what we are trying to find. Often this will involve checking and tracking units, building a table, or even finding a formula for the function being used to model the problem. The solution pathway is your path to the answer. Before you try to solve the problem, try to make a roadmap for yourself. In this case, we need to first find the equation for the two functions. Second, we're going to find the intersection point of the two functions. Then we'll be able to look to see where the y of m, or the U-Haul function, is smaller, and thus a better option. In step 5, we want to find a formula for the functions when needed. In this case, they are needed. So we need to find the linear cost function, which traditionally in math are represented by f of x equals b plus mx, or mx plus b. In this context, b is going to represent the fixed or upfront cost, m is the rate per mile, and x is going to be the miles driven. So x will be left as the variable in these functions. So for the U-Haul function, we should write y of x is equal to $20 plus 59 cents, or 0.59 times x, miles driven. And for the budget rental, we'll say b of x is equal to the $16 upfront cost fee plus 63 cents per mile, or x. Now let's look at step 6. We need to solve or evaluate using the formula you found for the desired quantities. In this case, we want to find the intersection point, so we'll set y of x equal to b of x and solve. We'll take the function 20 plus 0.59x and set it equal to 16 plus 0.63x. To solve this, we want to get all of our x's to one side, so I'll subtract 0.63x from both sides. And let's go ahead and subtract 20 to both the left and right hand side. Totaling this up, our 20s cancel out. 0.59 minus 0.63 is going to give us 0.04x, and that's going to be equal to, these x's cancel, and that's equal to -4. The last step will be to divide both sides by -0.04. And we get x is equal to 100, which represents 100 miles. So this means that if we drive 100 miles, the cost of renting a U-Haul or a budget truck will be exactly the same. If we wanted to find the cost, we can plug 100 into either the y or b function. In this case, I'll plug it into the y function. So y of 100 is 20 plus 0.59 times 100. And that will be 20 plus 59, or $79. So when 100 miles is driven, the cost of renting the truck from either U-Haul or budget is exactly the same. It would be $79. It's important to look back at the solution pathway to see that we're not actually done. We found the equations, we found the intersection point, but now we need to determine when the y of x function is smaller than the b of x function. Let's go over to Desmos and look at the graphs of these functions. I've opened up a new Desmos graphing calculator window. On the left-hand side, I've entered the formula for the U-Haul function, y of x, and the budget function, b of x. These graphs will be displayed in orange and blue, respectively. Oftentimes when you enter the function on the left-hand side, you will not immediately see the graph in the graphing window on the right. This is because Desmos defaults to a 10 by 10 viewing screen. There's a few things you can do to expand the window. You can use the mouse to scroll in and out. You can use the zoom in and out buttons on the right-hand side, or you can use the wrench to reset the window. I'm going to reset the window parameters for the x-axis to be from -5 to 200, and for the y-axis, I'm also going to go from -5 to 200. And we can see our two functions in orange and blue here. I've also labeled them for the U-Haul function and the budget function. We can see our intersection point for these two graphs is 179. That represents if we drive 100 miles, the cost for both companies will be the same, $79. But remember, the question was, which is the better option? And so we can see that at the beginning, the U-Haul function is above the budget function. This means that the U-Haul van or the U-Haul truck will cost more than a renting from budget. After they intersect, what happens as we move along, then the truck from the budget rental company costs more than the U-Haul company. So essentially, if you're going to drive more than 100 miles, it would be better to rent from U-Haul than from budget. Now, looking at the two functions, we can see that U-Haul has a higher upfront cost than budget, but a lower rate. So in the long run, it's better that you go with the smaller rate because you'll be paying less per mile. Step 7, where we reflect on whether your answer is reasonable for the given situation and whether it makes sense mathematically. So we found that U-Haul has a slightly higher upfront fee of $20, but a cheaper rate per mile at 59 cents per mile. Budget has a cheaper upfront fee of $16, but a more expensive rate per mile at 63 cents per mile. So it makes sense that at some distance, U-Haul will be a cheaper alternative since the rate is cheaper. Now, we have done a lot in this problem and in this video, so that's why step 8 is critical. This is when we want to clearly convey your results using an appropriate units and answer in full sentences when appropriate, either by looking at the graph or by noting that the y of x is growing at a slower rate. We can conclude that U-Haul will be at the cheaper price when more than 100 miles are driven. And that's it for this video. Thanks for watching.